Okay, let's go ahead and get started.
Lovely. Want to replace it?
Okay, good morning. Welcome to the final exam review for Math 151. Okay, the first thing I have here, introduction to graphing. And most of you are my students, so what's the basics of graphing? Anything that you're graphing. You have to find what? You have to find points, right? If you're going to graph a line, anything that you're going to graph, and to keep it organized, right, you find a table of values. And that table of values is going to give you the points that you're going to plot. Do I have a computer available here or not? Do I have a computer available?
Yeah.
Okay.
You want to use the computer?
I want to see if it has the TI-84, the calculator. You guys brought your calculators?
Yes, ma'am.
Okay. Oh, well, she does that. For example, if we're going to graph a quadratic, the first exercise right there is to graph a quadratic. First of all, you already know how the basic graph is going to look because you know most of the transformations, right, that are available for quadratics. We know if we're adding a number to the x inside the square, what do? That will move the quadratic left or right? If it's positive, it will move it to the negative side. If that number is negative, it will move it to the right, or to the positive side. Now, if there's a number added or subtracted to the x squared, like for example, the first exercise, it says graph that. You have an idea in your mind how's that going to look, right? How's that going to look?
It's going to be a parabola.
It's going to be a parabola opening up,
-1.
basic graph, and translate it down 1, right? So you have an idea. If you do a sketch, you have an idea that's going to look something like that. Now, we're not asking you for a sketch, right? So what every professor wants to see is a table of values. Now, you do have a calculator. You know how to find a table of values in your calculator, right? Plug it in, or just plug it in, right? So you have your x, you have your f of x, find values of x. Could be -2, -1, 0, 1, and 2. Now, to find the values of f of x, what you're going to do is you're going to substitute that x in the x and then find the value of y. And those values are going to be 3, 0, -1, 0, 3. And you can also do that in your calculator or check it with your calculator. But it's very important that you do that when you're graphing, right? Because that way, your instructor is going to know that you know what you're doing, and then go ahead and plot the points, right? It's going to be something like that. -2. There you go. That's what you'll do to graph that. Now, let's go to distance formula, midpoint, equation of a circle. Let's go to slope and equation of a line. What is the formula for slope?
MX plus B. Or something. Yeah.
Okay, what do you need to find the slope? 2 points. Any 2 points, right? You get 2 points. Label the 2 points and substitute directly into the formula. Now, once you have the slope, you use the standard linear equation, or you use the point slope. You substitute in that formula, and then if you substitute in this one, you have to make sure that at the end, you put it in standard form. This is the y equals mx plus b, right? M being what? What is m? Slope. And b?
Y-intercept.
The y-intercept. Now, those are the basics of linear equations. Now, let's talk about important stuff here. Now that you have a linear equation, if I give you a linear equation, right, and I give you a point, and I ask you to find parallel and perpendicular lines to the line. And obviously, it's going to be something like this. The equation of the line that is perpendicular to this. Okay. You know the slope, the standard equation of the line. So with that, you're going to identify what? You're going to identify your slope. That's the most important thing, right? The slope is that number that is always, always multiplying that x. When that equation is solved for y. If that equation is not solved for y, you have to solve for y first, and then that number that's multiplying the x is going to be the slope. Now, what do we know about perpendicular lines? Slopes are what?
Opposite 501.
Opposite reciprocal, right? So the slope of this line that I'm giving you is 1 over 5. The slope of the line that is perpendicular, that is the line that I'm looking for, is the opposite sign, and it's going to be 5 over 1, which is 5. Now I give you a point, negative 3, 2. Now you use the slope and the point, and you use your point slope equation to find the equation of that line that is perpendicular to this one. Okay, this will be positive, right? Negative minus negative, that will be positive, so that's why it's minus 15. So it's y equals. X. Okay, any questions? Now, there's another type of line that we can find. It's the line that is parallel, right? Parallel. I don't have an example here, but let's say okay, so you do have to understand the equation of the lines, but most important, right, that is the base for this. The things that you need to know is when you're finding an equation that is perpendicular to an equation, The slope is the opposite of the reciprocal, right? You have to change the sign, and you also have to find the reciprocal. So from 1/5, we went to -5 in the perpendicular sign. Now, if you're going to find the equation of the line that is parallel to that equation, what happens with the slopes?
Has to be the same.
The same. So the slope of that parallel line that I'm looking for is going to be what? 1/5. Now, again, you have the slope, and you have a point. Now you use the point-slope equation again to find the equation of the line. And this will be x1, y1, and you have y minus y1 equals m x minus x1. -2/5 minus 5, and you guys can do that in your calculator. Okay, remember, fractions, there's going to be a lot of fractions in the test, right? But what do you do? How do you do those? If you have trouble doing them, that's why you have a calculator. The calculator, you enter the fraction in your calculator, and then you ask for the answer in fraction form, and it will give you the fraction. So -2/5 minus 5 is what? -2/5 minus 5?
-27/5.
Yes. That would be your equation. So those are the things that you need to remember. You can use the slope intercept. Can you use, even though we do not have the intercept, can you use this one? Can you use the slope intercept to find the equation of the line instead of the point slope? Sure you can, right? Sure you can. How would you do that? You have m, and you have to remember how to find m, right? If it's parallel, it's the same m. If it is perpendicular, it's the opposite of the reciprocal. Now, you have m, so you have an x and you have an y. Can you find b? That's the only thing you need to find, b. Go ahead and substitute the y. You found b. Now you can write the equation in standard form. Always, the slope intercept is the standard form, right? What is your m? 1/5 x plus or minus b, right? Plus b, which is negative. So you can actually use both of them. Okay, that's all for lines. Let's go over to increasing and decreasing functions. You guys, none of you have the review printed out? Only one of you?
I do.
You do? Can you please get it out, because I don't have a way to show you these exercises right here. And if you guys get in small groups, you can all see what I'm talking about right here. We are in chapter 2. Okay, so you can look at his, you can look at his. He has it. You guys don't have it? Okay, just move with these two in here so you can see this problem here in chapter 2. Now we're talking about increasing, decreasing, and constant. When the behavior of a function. Now you see a graph in there, right? It says exercise 18. Exercise 18. Now if the function is increasing, what happens? How does it look? An increasing function looks Like it's going up from left to right, right? It looks increasing. If it is decreasing, it's going to be slanted down. It looks like it's going down from left to right, and constant will be what? Horizontal line. Okay, let's look at that exercise 18. Determine whether the function is increasing, decreasing, and constant. Write your solution in interval notation. So you have to, if you don't remember interval notation, let's review that real quick. Interval notation, right? Now, when we're talking about increasing, decreasing, and constant, do we ever use an interval notation with brackets or close endpoints? I'm going to try to make a sketch over here of the graph for the camera. But it's kind of difficult, but I'm going to try to do that. Okay. It's going to look something like this problem, okay? Now, let's look at when is that function increasing? When is it look that it's going up? Wait.
From 3 to 1.
My sketch is not that good, but anyway. Okay, it looks like it's increasing. It's going, this part over here looks like it's decreasing, right? So we're looking at the increasing. So it's going from -3, and at this point, this is the maximum point of this parabola shape, then it's going to start going down. So from -3 to -1. Now, what I was talking about, do we include any endpoints when we're talking about increasing and decreasing? We never do, right? When we talk about, only when we talk about increasing and decreasing, we never use bracket. We never include a point because the same point cannot be increasing and then decreasing. That's why we never include the endpoints in increasing and decreasing. Okay, what else? Is there any other part that sketch looks like it's increasing? How about decreasing? Okay, from where? We start this part, right? So we start where?
-infinity.
To where?
-3.
What else?
4 to positive infinity.
-1
Oh, well,
to
-1 to 1
Negative
and then.
From -1 to 1? You can write it like that, from -1 to 1. Union, what else? 4 to infinity, right? So those three. Is there a place which is constant? Right here, right? Right here is constant. It's supposed to be a horizontal line.
Yeah, basically.
So from 1 to 4 is constant, right?
That's not right. No, you don't put it right.
Now let's talk about variation. Let's talk about variation, next topic. How many types of variations we have? We have direct variation, inverse, joint variation, right? This is the only whiteboard that's in here, right? Okay. So when we talk about variation, we have general equations of variation. And we have 3 types. Direct. Okay, those are the general equations of variations. Normally, in a problem, you have, the first thing you have to identify which type of variation, then you find your general equation, then you need to find your k. And the problem will tell you, in this case, will tell you a value for x and for y that you're going to substitute to get your k. Same for this one, and same for this one. I also have to give you a value for c in this one. You have to find the value of k, and that value of k is going to give you the specific equation of variation for that problem. Let's look at that problem, exercise 33. Exercise 33. It says the gravitational force between two objects is directly proportional to their masses m1 and m2 and is inversely proportional to the square of the distance between them. What is the equation of variation? Let's start right there. Now, there's two different types of variations here, right? There's two different sides. Which one is the first one?
Direct.
It says directly proportional. Directly proportional is what? Direct variation. So we're talking that we're going to multiply something to that k. What is it that we're going to multiply? It's directly proportional to their masses m1 and m2. Those are the two variables that we're going to multiply to the k because those two are directly proportional. Then there's another type of variation that says inversely proportional to the square of the distance r between them. Inversely proportional will be which type of variation? Indirect or inverse, right? Should be inverse. Inverse variation. So we're talking about that we are going to divide that variable. So what is it, that variable that we're going to divide? R what?
Square.
R square, right? Inversely proportional to the square of the distance r. That will be your equation of variation. This problem does not give you any values, so you can find k. It doesn't give you any values. Let's say no. Now, any questions on variations? No? Okay, let's talk about quadratics. How do we solve quadratics? First, we always try to factor, right? Because factor is easy. When you factor, you always try to find a common factor between all the terms, and you do that first, and then you try the factor. If you can factor, you can either complete the square, or you can use quadratic formula. I'm a fan of quadratic formula because it's just easy. If you like completing the square, then that's what you're going to use, okay? And how do you complete the square? What's the number that you have to add on both sides?
Half of the square of b or something. Square of half of b.
I have a good example here. I'm going to do one for completing the square. If I ask you to solve this problem, by completing the square. So the first step that you're going to do is you're going to move that constant to the other side of the equal sign. Right? Now we're going to complete the square on this side. Now we have a number that we have to add on both sides of the equations, right? Which one is that number?
It'll be 4. It's half of 2, or half of 4 squared is 4.
me find that number right here. That's b, right? 4 divided by 2 square equals 2 square.
That'd be 11. X squared plus 4x.
11, I'm sorry. Yeah, thank you. Thank you. I left that one out. So now, when we complete the square, the reason that we complete the square in there is that we can now do what?
Have a perfect square.
We have a perfect square and we can factor into the square of a binomial. And that it's always going to be the same. You're going to be x. It's going to be x. Now, that number that you're going to add or subtract there, it's always going to be the number that you squared to get that 4 or to get that number that you add on both sides. If that number is positive, then it's going to be plus. If that number is negative, that number that you square, then that's going to be a minus. It's always that number. Now, how do you solve this? We use what? Principle of square roots, right? Take the square roots on both sides. What do you have to remember when you use the principle of square roots? You have to remember something.
One side you have to do the other.
Every time you use the principle of square roots to do anything, you have to remember, important, very important. I heard something. Plus or minus. Plus or minus. Every time you use the principle of square root, remember that plus or minus. So now we have x plus 2 equals plus or minus square root of 15. Oops. Now those are your two answers. Negative 2 plus or minus the square root of 15. Now, quadratic formula. All of you guys are experts in quadratic formula by now. Let's go ahead and do an example for that one. So you can, if you try to factor is always easy. So you always try to do that first now. But completing the square and quadratic formula, it works on everything. Factoring doesn't work on all of them, right? Also, only some of them you can factor, but not all of them. But completing the square quadratic formula, they always work. So what do you have to do here? What's your A, B, and C?
I'm going to move the 2 over.
Yes, that's the first thing you do, right? You always have to make it equal to 0, 1. That will help you identify that C or whatever term is over here. That will help you identify. Now you can identify your A. A lot of students do that. A lot of students try to go straight to A, B, and C, and then they get C equals to negative 2. And then that's when the mistake comes. And then once you do that, what do you have to do?
Plug A, B, and
Directly
C
into the formula.
calculator.
B squared minus 4 times 3 times 2 over 2 times 3. (24) 49 minus 24 is what? 25? Over 6? Equals 7. So I have two answers here, right? 7 plus 5 over 6 and 7 minus 5 over 6. So I have x equals 7,
2.
12 over 6 is 2, and 2 over 6 is what?
1/3.
1/3. Vertex. How do you find the vertex? What's the formula for vertex? I'm trying to go over a lot of concepts here real quick, but if you guys have questions or something, stop me, okay? Remember vertex? How do you find the vertex? Quadratics 2. Minus b over 2a, and then you substitute that number in your function, and you find the value of y corresponding to that x. Find the vertex. Six over 3. We found the x, right? Minus b over 2a. Again, this b, negative 6, becomes positive with that negative sign over 2 times a, and a is 3/2. Okay, you find the x. How do you find the y? Plug it in, right? That's 2. Oh, I got it right here. Negative 1. You do that in your calculator, right? Mm-hmm. You don't have to do it in your brain, in your mind. You just do it in the calculator. Now, applications. Applications of vertex. What is vertex good for? Every time you see a problem that asks you for what's the maximum or what's the minimum of this, right? More than likely, they're going to be asking you for the vertex. Okay, they're going to be giving you, you know how parabolas behave, right? If that x square term is positive, the parabola is going to be opening up. If that x squared term is negative, then the parabola is going to be opening down, and more than likely, the situation, right, is going to give you a quadratic, even opening up or down, and they're going to ask you, what's the maximum area, or what's the maximum of something, or what's the minimum? That all they're asking is for the vertex, that's all. All they're asking is for the vertex, and I have an example right here we're going to go through. And after you do that by hand, right? After you do that by hand, how do you check your maximums or minimum? Graph it in your calculator. You know how to find the maximum, you know how to find the minimum, right? Anybody get any question on how to find that in the calculator? No? So you remember, your calculator, that's your answer key, right? You have your answer right there. Everything you do, you can also do in the calculator and check it. Where was my problem? Oh, right here. It says a model rocket is launched with an initial velocity of, and I'm talking, this is problem 3.3.4, if you guys have your reviews in front of you. A model rocket is launched with an initial velocity of 112 feet per second from a launch pad at a height of 20 feet. The equation of motion is S of t. They give you the equation of motion for this rocket is Now it says determine when the rocket reaches its maximum height and find that maximum height. So you saw that over there, right? Maximum. That means what? Vertex, right? Especially, just look at this equation and think about it, right? This is a quadratic. So this quadratic, the square term is negative, so it's going to look like this. So they're asking me for maximum. What are they asking me for? A vertex. That's roughly what, 3.5? And we're talking about seconds, right? Feet per second, yeah. So this will be what? Roughly about 3.5 seconds? It is 3.5 seconds. So the rocket is going to reach its maximum height at 3.5 seconds. Now it also asks you for the maximum height. What's the maximum height? $216. $216 feet there. Okay, let's talk about equations and inequalities with absolute value. Leave that one in there. Okay, if we have an equation with absolute value, basically we have what? Basically, we have to solve how many equations? 2, right? In order to take those absolute value bars out, we need to do what?
Do one positive, one negative.
Yes. No, equals 6. Sorry. The first thing you're going to do is to isolate that absolute value on one side of the equation. Remember, you have to isolate it first before you do anything else, right? If there's a number that's added or subtracted to it or from it, then you need to transfer that to the other side. If there's a number that is multiplying, if there's a number, sometimes there's a number that's multiplying that absolute value, then you have to divide by it first on both sides, right? Now from here, now that it's isolated, now we're going to go ahead and solve my two equations, right? In order to take those absolute value bars out, I have to make that expression equal to 1, and I have to make that expression equal to what? To -1, right? So from here you have 2x equals 1 plus 1, which is 2x equals 2. And from this one you get -1 plus 1, that will be 0, right? Now let's talk about inequalities with absolute value. Now basically inequalities with absolute value, we transform them into compound inequalities, right? So that one, you look at the sign, right? That's the first thing you look at. First you have to isolate that absolute value, just like in the equations. But now you look at this, right? If it is less than, that basically gives you an AND compound. That will be an AND, right? And that's what you solve. So x is in between -17 and 1. So we write that in interval notation, right? Normally, we write inequalities, solutions in interval notation. So which are my endpoints? I'm going from -17 to 1. Am I including any of those two? Am I including them? No. So I use parentheses. No, right? Because why? Because I don't have an equal sign. Now, the other case of inequalities with absolute value would be if you have greater, right? That one is less than. You have a greater than. This case, greater than or equal to. So this gives a what? Compound. Or compound, right? Compound inequality, but this is going to be or. We're going to separate into two different inequalities. One is going to be and just remember this, every time you see absolute value, it'll be equations or inequalities, just remember that you have to solve two, right? You have to solve two because a lot of students, and I've seen this in tests before, a lot of students just do one side. For the equation, they just do one side. For the inequality, they just do one side. And they forget that second side, right? You have to do two inequalities. You're going to have two different things to solve. The same for the equations. And then you just solve this. Now we have to write an or compound interval notation for the solution set. What's that going to be? Now remember, when you're going to write the interval notation, sometimes it helps to graph. Sometimes, sometimes this says that it's going to be everything before negative 17, right? I always use that inequality symbol as an arrow. That arrow is pointing that way, to the negative side. So if I have negative 17 here, I'm going to use a bracket, right? Because I have that equal sign. Everything that goes that way. And then I do the same with the 1. This one tells me everything greater than 1, right? Including the 1. I use that symbol as an arrow. So everything that way. So it helps when you have the graph. You're going to include these 2 sets, right? These 2 sets. So this one, where does it start? Negative infinity. And it ends where? Now, is that included? The 17 is included? How about this one? No, right?
It's never included.
Infinity signs are never included, right? Because you don't know what number that is. And this one starts where? And ends? Infinity. There you go. Any questions on that? I think I missed something. Missing something here. Hold on. Composition of functions. Okay, compositions. What do we have? F composition G or G composition F, right? Those are the definitions. You guys are very quiet. You're either sleeping or you're very focused on the material. Or sleeping. That could be a possibility. Okay. Let me see. Let's do an example. And I'm looking at example 2.3, 2.3.1 actually over there in your review. 2.3.1, that example. It says exercise 24. So we're going to find F composition G of X. Now, let's find the domain. The domain, right? What will be the domain?
Positive infinity, negative infinity.
Negative infinity to positive.
We have a variable in the denominator, right? Remember, this is f of g of x, right? G of x is what goes in the x. What happens with the domain of f of x? There's something there. We're dividing by a variable, so that variable cannot be what?
0.
Cannot be 0 because we can divide by 0. So basically, what's going to go in this x is going to be what? G of x, right? So g of x cannot be 0. What number will make g of x 0? What number will make this 0? 1, right? 1 minus 1 equals 0. So the domain of this function is what?
All real numbers except for 1.
The set of all x such that x cannot be 1. Can it be negative 1?
Yes.
Because I thought it was negative 1 and positive 1.
Now look at this.
Oh, you square.
It's a square. It's a square, so it doesn't matter if it's positive or negative, right? All right. Because if you substitute negative 1 in there and you square it, it's positive 1 anyway, so 1 minus 1 equals 0. Now let's find, what's the next one? Let me see. F composition F. That is 1 over, now instead of x, what are we going to write in there?
1 over x.
Instead of x, we're going to write 1 over x. That's equal to what? X, right? Now, do we have to exclude anything from that domain? What do we need to exclude from that domain? We only have one function, right? It's f of x, 1 over x. What number we cannot have in that function? 0, right? We cannot divide by 0. Do a time check. 10:20. This ends at what time? 10:40? Okay, so we have 20 minutes. Huh? Until 11:05? Okay. So they told me 9:25 to 10:40. Well, it depends on the people here. If you guys want to stay, we'll stay.
Yes, we'll see.
Elizabeth, you're the only one. Everybody else is like, I don't know, maybe 10:40 will be okay.
The better prepared we are, the better we're going to do.
There you go. Okay, what are we going to talk about now? My next topic is going to be inverse functions. I am skipping a lot of topics because I don't think I'm going to have time to go through all of them. But if you guys have any questions on anything I'm skipping, let me know. We go through it. Now, how do you find inverse?
I don't like inverse.
I'm in chapter 5.
Talking about matrices?
No, inverse functions. And if you follow these steps, you'll always, it's a step, right? It's a process. If you follow the steps, you always get it right. So the first thing you do is you change that for what?
Y.
For y. Then what do?
Oh, you gotta switch the x and the y.
Switch the variables, right? And then you solve for y. This will be the inverse, right? So to denote that this is the inverse, we're going to change that y for, what's the notation of inverse?
-1.
That's the notation.
So positive 7 over 3. Por eso I got negative 7 over 3.
No, this negative over here. Oh, you had the different sign over here. It's positive. Inverse.
Also put x minus 7.
Okay. Any questions on that? Next topic, we keep moving. Compound interest. These compound interest problems, they just tend to find a way to every final. I don't know why. Okay, now I'm looking at 5.2, 5.2.2 applications, which is the interest compound. Exercise 80. Says $100 is invested at 3% interest compounded quarterly. Find a function for the amount in the account after T years. Use the model to find the amount of money in the account after 20 years. So the first thing you're going to look at is interest compounded quarterly. So you know it's compound interest, so you have to use the formula for compound interest. There's a different formula for simple interest. It will be compound. There's another one for what? Compounded continuously, right? Now, what is A?
This is the total amount.
Future amount. What is P?
Amount invested.
The principal. What is R?
Rate.
And what is N?
Time.
N, no. T is time. N is what? Number of compounding periods per year. If it is quarterly, how many times we're compounding?
4.
4 times. So we have, in this problem, 100, right, is the principal. So P equals 100. What else do we have? 3% interest, so R. Then we have, what else? Compounded quarterly, so N equals 4. And that's all we need. Okay, how do we use R? Do we use percents?
No.
Do we use the percent or we use the decimal form?
We use this.
Decimal form, right? Four. Now it says use the model. First says find a function for the amount in the account after t years, right? So that means you substitute everything except t. And you can actually do this in your calculator. How much is this if you do this in your calculator?
0.2575.
1 plus this, 0.03 divided by 4.
1.0075.
There you go. That's after t years. But then the problem also asks you a second question. Use the model to find the amount of money in the account after 20 years. So what are they telling you? They're telling you that t equals 20. Substitute 20 there and solve. And that is how much?
About 116.
Hmm?
About 116 point something.
No, should be something else.
Maybe just a second. 181.
181.8. So after 20 years, that $100 at 3% interest, you're going to have 181.80. So please don't invest at 3% because you're not going to make much. That's what you learn from this problem. Don't invest at 3% ever. Okay. What's my next topic?
Actually, if you invest in a CD right now at 3%, that's actually a pretty good rate.
For a CD, it is, yes. For a CD, it's, yeah. But it's not good for retirement accounts. Oh, we have talked about retirement accounts before in my class. We use CDs for long-term goal, for medium-term goals, right? 3 to 5 years. That's what we use CDs for. But retirement long-term accounts, then different. Okay, converting between exponential equations and logarithmic equation and converting between exponential equations and logarithms and logarithmic equations. If I said something wrong, what do we need to know how to do that? That's how we solve, right? We solve exponentials with logarithm and we solve logarithm with exponentials. Okay, how do we convert this to logarithmic? The base, right? The base is the number that has the exponent. That's going to be the base of the logarithm. Then you have the 625. And the log, the actual log is what? It's a what? It's the exponent, right? That will be the exponent. Another example.
But what we have to do to convert to logarithmic form?
Yes, same. Another example, convert to logarithm. So this is log base e of 1,000 equals t, right? Same thing. The base is the base of the log, then you have the number, then the actual logarithm is the exponent. Now, what is log base e? What is that? If we have, do we ever use a log base e, or do we use something else?
ln.
I was gonna say, don't we use ln for that one?
We use ln, right? We don't use log base e. Now we're going to convert to exponential form. Okay, first thing I look at is the base, right? The base is the number that has the exponent that's equal to the number that it's in the log. Now convert, next one is same thing, right? ln is what? ln is the log base e of 5 equals t. So we have e to the t equals 5. Let's solve equations. There's two ways of solving exponential equations. How do you do that? How do you solve exponential equations? Are using logs, right? So let's do this example. I have one example right here. So let's try to isolate that term that has the x, right? Remember, every time we're going to solve for a variable, we isolate that variable. So I'm going to isolate, that variable is an exponent right now. So I'm going to try to isolate that base with that exponent that has the variable. It's 5. Now we said that we solve exponentials with logarithms, right? So let's convert this to a logarithm. What is it? And this is ln. How do you convert it to a logarithm?
ln 1/3 is equal to x.
Log, let's do it with logs. Log base e of 5 equals x. So that is what? X equals what? ln of 5, right? And the natural log of 5, you can do that in your calculators, and all of you know how to do that. It's the ln button in your calculator. This is fine. Now let's solve logarithmic equations. And how do we solve logarithmic equations?
With exponents.
With exponentials. And here I'm looking at exercise 94, 5.5.2. And I did not go over this today, but you should go. The first thing you have to do in there is try to write it as a single log. And why do you want to try to write it as a single log? Because you want to be able to convert to an exponent, right? To an exponential.
So you would use the power rule?
Hmm?
You would use the power rule?
In this case, you will use the power rule, right? Because the logs are what? When they're same base, first of all, they're the same base, and you're adding them. Because you're adding them, that's the same thing as if you're what? Multiplying them. So you can multiply that if you want. That is what? X squared
Squared minus 10x plus 21.
minus 10x plus 21. Now how do we solve that? With, let's make it into an exponential. We just did it. How do we do that?
Maybe
The
10
base?
to the 10 to the 5th is equal to x squared minus 10x plus 21. 2.
Now 2 to the 5 is what? 32? So we have x squared minus 10x plus 21 minus 32. And that's what? 11 minus 11. And what do you have? You have a quadratic. Can you solve that? This one is easy. This one you can factor. And that's x. 11 is 11 and 1 minus and plus.
10 and 1?
No, 11 and 1. 11 times 1, and then minus 11 plus 1 is negative 10. And then after that, you apply the zero product property. So x minus 11 equals 0, and x plus 1 equals 0. I hope you can see that. I get x equals 11 and x equals negative 1. Now we should always check, right? You should always check your answers. Do we have the log of a negative number? Do we ever do that? Right?
So switch it up.
So it can't be negative 1.
No. So that's not an answer. So we get x equals to 11. My next topic is going to be, let's do something with matrices. We solve system of equations with matrices. The normal method will be the Gauss-Jordan elimination, right? The Gauss-Jordan elimination. For the first thing you have to do is to write the augmented matrix, which will consist, and if you look at 9.2, exercise 105, it's 1040. It's 1040. So if you guys have something else to do, because I know it was announced until 1040, but I'm going to continue if you guys, if some of you want to stay. But if you guys have class, then you're welcome to leave. Thank you for coming. Okay, solving of system. Huh?
How about like a 2-minute break?
Well, okay. Go to the bathroom. We'll continue. Okay, Gauss-Jordan elimination, because how do you write the augmented matrix? I'm going to write the augmented matrix for exercise 105, but then I'm going to solve a smaller system because I don't think I'm going to have a lot of time.
Thank you.
Bye.
Thank you.
Bye. So it's very important that you know how to write the augmented matrix, because the augmented matrix is what you can enter into your calculator, right? Not saying that you don't have to do it by hand. You're going to have to do it by hand, but with the calculator, what happens?
Check.
It will give you the answer. It will give you the answer. So basically, we write the matrix with all the coefficients on one side. And the constants on the other. That will be the augmented matrix. Now let's talk about the Gauss-Jordan elimination, because I want to do an example. I'm going to do a smaller example of that one. Just to show you the method. But you can do Gauss-Jordan elimination on this one too, right? It will be what? This one already has a 1. Then you're going to use that one to eliminate these two. Then when these two are 0, then you make this one a 1. Then you use that one to eliminate this. Then you make this one a 1. And that's basically it. Then you use that one to go up and eliminate up, because this is going to be at 1 here. So you're going to use that one to eliminate up and this one to eliminate up, basically. Let's do one smaller one. And again, the same method will apply to the 3 by 3, but we're just going to do that one real quick. Okay, how do we solve that one? And there's many ways to do this, right? You can do different things as long as you follow the only three things that you actually can do, which is you can interchange in either one of them. You can multiply each row by, you can interchange either row, right? Either row, you can interchange them. You can multiply them by a number and then add it to another one. That's basically the things that you can do. Now, looking at that one, I have a 3 and I have a 2. And I want to make one of them a 1. So it's very convenient, right? Very convenient that way, because if I multiply one of them, if I multiply this one by -1 and I add it to that one, you're going to have a 1 in the first one. So I have the first one's 3, 4, 22, and I multiply this one by -3 and 4. When you add, you get 1, 1, 26. So I will be the system that you have will be 1, 1, 26, and 2, 3, -4. Now that you have a 1, you want to eliminate that. Remember the reduced row echelon form? Basically what we want is, this is your augmented matrix. You want 1s in your diagonal and 0s everywhere else. That is called the reduced row echelon form. That's what you look into in the calculator too. It's RREF. And then the numbers that they're going to give you over here, basically it's going to be what? X, Y, and Z. So this one is a smaller one, so what I'm looking for is a 1 here, a 1 here, and 0s here and there. Now, how do you eliminate that 2?
Times 2.
You multiply the first one times -2, and you add it to that one. So it will be -2, -2, and that is what?
-52.
52. You get 0, 1, 56, -56. Now that will be my second column, right? The first one stays the same, and I'm going to continue this way. 1, 1, 26, 0, 1, -56. So I already have a 0 here, and just conveniently, this one is also a 1, so I don't have to do that one. But what do I have to do now?
You have to make that upper 1, second one, a 0.
Yeah, so you have to multiply, and I'm going to use the second one to eliminate that one, right? So I'm going to multiply this one times -2. I'm going to add it to that one. Times -1, so it's 0, -1, and 56. And then it is 1, 1, 26. You get 1, 0, and this is -30. It should be 26 and -56. Oh, this is positive. There you go. 82. So the one that I used to eliminate was this one, which it was the one that I multiplied times -1. So that one stays the same. 0, 1, -56. And row 1 becomes 1, 0, 82. Once we have it there, we'll have the solution, right? The solution will be x equals what? 82, and y equals -56. And I'm going to write the solution here. But I think I'm going to leave it here for right now. And I hope you guys enjoyed it. And